your work has taken you all over the world. How do you balance work and home life with all of your traveling?
Well, it's interesting. It was, for many years, it was mainly domestic. Once over the world, except for a welding stint where I was in France for that, and a couple trips to Europe for technology issues. I usually was traveling to the plants and within the U.S. And, you know, I didn't give it much thought. Well, when the children were small, I was in Baltimore all the time, almost. And so I would call in at night after I had eaten dinner, usually, and would talk to them and give them a good night story. And the good night stories usually were some aspect of steel making, of the, I mean, obviously it wasn't the straight chemistry and things like that, in the sense of, because they knew nothing about chemistry and things like that. But you can really, you know, use your imagination and have little people bring in, you know, little grains of chrome or iron, which gets very hot and starts dripping between the fingers. Obviously, you're not, you know, things like that. I mean, you can go on. And so they actually, in practice, they ended up learning how to make stainless. They didn't know that. Later on, once they were in high school and they learned some chemistry, they started realizing that was kind of, they would ask me, were you telling us how to make steel? I said, yeah, that's what I was doing. And so, yeah, that was one of the things that, you know, it was always there with it. And I had to organize them, you know, my husband and I had to organize that the kids were taken care of, they would be picked up. There was food in the house to eat for everybody, etc. But it's, you know, that we didn't consider it, I mean, I have two children, we never considered it to be a major showstopper or something like that. I mean, the one or the other, I mean, there were a couple of times when I couldn't travel because one of the kids was sick or something happened. But in general, that was not an issue. The kids knew that I might come home, say, I'm leaving in 2 hours, I need to pack, and that was it. I mean, they grew up with that. They did not really think about it as being different or being unusual.
So they were just used to you traveling all the time, and it's just, no, it's...
Yeah, that's part of what mother does.
Yeah,
yeah, exactly. They never, because I was doing it since they were born. So, but as I say, I mean, my husband was obviously in town, so if something needed to be taken care of, he could step in, and we did have help. I mean, I'm not, because, you know, one person who's working also full-time is very difficult to take care, you know, to do all the other things. But no, they knew that I travel. I mean, to the point that they would be asked at the beginning of the week, they would ask me if I was going to be in town or not.
Did they ever get excited about where you were traveling?
When they were very little, they were excited that I traveled because they would go to McDonald's.
Mom's out, that means we get McDonald's this week.
Yes, exactly. And they didn't get that when I was home. The other big thing was ARMCO had open house every so often. And so I always made sure that my daughter was in the BOF shop when she was probably about 2 months old for an open house. No, obviously she doesn't remember. And I mean, but I used to kid her that she was in the steel mill since, you know, basically since birth, but she had to go into steel. She did not. Because of that. But yeah, no, they had an open house, and my husband and I and the baby went along, and I introduced them to both of them to all the people I was working with and things like that. But having open houses at the steel mill really helped, because then they could at least imagine what I was talking about. Because remember, this was all before YouTube and things like that. So it was, they couldn't really relate when I would say it's a big, or a very big, or a very hot, or loud and noisy, or dirty. I mean, you cannot really relate to it unless you have seen it. So for the open houses, not only would I bring them, but the school my kids went to was very accommodating. And if ARMCO had an open house, they all brought pretty much all the grades. I mean, we couldn't bring the really small young kids because it would be a safety issue. I mean, but we would bring everybody in. And let me tell you that not only did the kids remember, but the teachers still remember to this day going into the steel mill. And that's another way of how you get new people in. It's exposing others to some of these areas, some of these industries that you really have no way of entering unless you find out that you have an open house or there is something going on. And you can show that, you know, it's not what the Flintstones show.
Do you happen to know if any of them ended up in the steel industry?
I know some went into science, but not necessarily steel industry. I thought my son would be. And actually, he lived in Chicago many times and asked me one time, can you get me into one of the steel mills around here? So I talked to some people, and although he was not doing steel, I mean, or at all, but he wanted to continue from what he had seen and heard from all his life after then. So I was able to get him into one of the mills, I mean, for an open house or type of day. So, but yes, you know, we have to show. I mean, not just tell. We have to show what it is, what we can do. Yeah.
That's great. So, all right, after ARMCO and AK Steel, what did you do next?
Well, the Refractories group was slowly dissolved, and the equipment was auctioned off, really, test equipment. So I went into the process, a lot more process work, steel making. Again, it was mainly stainless and specialty steel. And after that, well, we went, he was separated, which is the nice way of saying that I was fired in 2003. And after that, I worked for ANH, which meaning A is for AP Green, N is for Narco, and H is for Harbison, and today it's HWI. For about a year and a half, working mainly in they were trying to get into the AOD business with fired dolomite brick. It did not work out, so we parted ways, I mean, on it. And at that point, I made my own company and have been independent, working as an independent refractory consultant in the steel and other in the heavy industry, usually heavy industry. Some of them have not been so heavy, but or what we think of as heavy industries, yeah.
So what inspired you to start your own consulting?
I was not moving. I was not going to be moving. And at that time, for me to work with the ANH, it was taken for granted I was going to be working from home. That was not as easy to get another position for that. So that's why I said, well, my choices are getting limited. I was seeing other people doing consulting work. I said, well, that sounds like a great way of doing things and continuing my career. And I went for it. So that's why I did it. And as I say, I couldnly move. I wouldn't move, let's say. Obviously, I could, but I'm centrally located. I said I have highways close by, and I have 2 airports. I don't need anything else.
So how has your company evolved over the years?
Well, when I started out, I was working almost exclusively steel, from either working for refractory companies going into the steelworks, or working with them for solving some issues, or for steel companies solving issues, again, refractories. And over the years, it has expanded. First, when I started working in aluminum, and did some work with silicon for solar panels. That was in Canada. I was doing some of that work, and I've expanded ever since. I mean, I don't go out to work to look for jobs. I do have a website, and I know that in some cases they tell me, we found you through your website, or we found you in LinkedIn. I mean, I'm not trying to advertise LinkedIn, but it does. I mean, it does give you a platform to showcase. And, so nowadays I do go in for failure analysis, but I also expert witness in legal cases. And there are a couple that I will not touch because they're just not something that I would feel comfortable doing. Mm-hmm. And I do quite a bit of insurance work, because when a unit goes down, be it steel, be it glass, copper, obviously I've worked in all of those, that is a big insurance claim. It's industrial, it's a production loss. Usually it's where the big numbers come in. It's not so much the refractory itself, mm-hmm. but the production loss, because they have to obviously make up for all of that. So insurance companies generally want to know why something happened. They do give you the time and usually the resources to actually investigate the failure. What went wrong? Why did it happen? Because they don't want it to happen again. I mean, that's really what it comes down to. But so it's been quite interesting. As I say, I've been in all of those. I've been in a lead melter, recycler of, that was not insurance, they had refractory issues, recycler of car batteries, which contain lead. Mm-hmm. So they have an electric furnace that charges that and to recover lead. The big issue there, of course, is safety, environmental issue with lead fumes and that was a MAC chrome lining. And we're in the middle of a big city, and that's about all I can tell you about them. But it's been very interesting. The different industries, and as I said before, you learn from one and you apply it to others, and how you look and how you approach it is quite different. So they've done much aluminum, what they call secondary aluminum. In other words, recycling aluminum, refining aluminum. It's not taking the bauxite and making it into aluminum or alumina. But so that's been interesting. I have had titanium smelting, copper smelting, many different things. And the big issue is many of the industry, especially the smelting side, and I was taking the ore and making it into a metal, they do not, each company develops their own technology and equipment. So in the steel, somebody says BOF, everybody knows pretty much what it looks like. Mm-hmm. You go to an engineering company and you order the BOF. Not in many other areas, the company develops their own, or invents their own equipment, lines it, and their own process. And it's all proprietary. And so to get information on basics, I mean, why did the refractory fail? Well, I need to know your process. I need to know how you do these things. And that becomes very challenging because you can't read up on anything. You can read up on the very, very basic studies of slags, of melting, of temperatures needed, but that's about all you can get because everything else is proprietary and it's not published, obviously.
So you mentioned your website and LinkedIn. How has networking and everybody that you've met throughout your career impacted your company?
They have, because the people that I've met are mainly in the steel side, because that's where I grew up in. They obviously have impacted it considerably. You know, I still work quite a bit in steel and things like that. And, you know, if I get a call, I say, if I get a call at 8 o'clock at night, I know that something bad happened somewhere. And I'm talking while putting together my suitcase. I don't know necessarily where I'm going, but I know I'm going to be going out very quickly. Training seminars, I mean, are scheduled, are planned. But my name is put forward because of all the networking. I mean, I'm considered part of the system. I'm trustworthy enough not only to come in, but to keep certain things, the propriety aspects. And every company has a certain amount of proprietary information. It stays proprietary after I go and things like that. And so that's how it has impacted having all this networking, having all these things. Is A, I can ask questions. B, they will give me work. They will suggest my name, you know. And when you're writing reports, especially, you know, my name is put forward in many areas. Although I work in steel, they may suggest my name in other areas, like maybe a methanol plant or some other thing. So that's how, you know. But then when I write a report, sometimes I'm not too sure about something, so I will actually use them as a sounding board. I mean, it's not using them, but we can discuss things. Is this, I mean, because I'm not that familiar with the process or the industry or things, is this logical? Does this make sense? You know, because one of the things, if you work in an office or you have other people to talk to, is you bounce ideas of them, you discuss things. If you work for yourself, you don't have that. So you have to find people really, if you know, that you feel comfortable doing those things. And most of us working on our own have certain people we will call or we will discuss things with, because you don't really want to, you can easily go down the wrong way if you're by yourself and you don't really have a check on your ideas and what you're thinking or how you're thinking about it.
So do you have any advice for people that are starting out in the refractory industry, like me?
Well, actually, learn as much as you can about all the systems, about the theoretical things. You may be working in steel, you may be working in aluminum later on. The challenges, the detail of the challenge will change of the different industries, but the overall challenges will not. You know, every industry will consume refractories. That's why they're called consumables, although the users usually don't like to think of it that way. And it's just the details of what attacks it, what are the nasties that they encounter, or why you use some materials are better for others. And you will also find out suddenly that you can take the knowledge that you take in one industry and transfer it to another industry in lining designs, or what to look for, how to look for it, what questions to ask, especially when you are looking for why did it fail. Usually it's not so difficult, you know, or what to consider if you're going to make a recommendation. So all of those things play together, and you will find some industries are stronger in some areas or some material uses than others. So you can transfer back and forth. But you know, and you also find that they pass each other. I mean, let's say aluminum was very strong in the basics of castables when I started out with castables, because Alcoa was in it. And then they had some purges and lost some of the technical people. So then the steel industry started using much more the monolithics. And so they learned how to install them, how to heat them, how to make sure that they made it. And the aluminum had some other issues at that point. So you keep going from seeing similar challenges from one industry to the other, and you can really learn from the different ones and apply them across the board. I mean, it's not a one-for-one, but you can really use that knowledge, and it helps really with the analysis of failure, or what you recommend, or how you look at things to go into different industries, because their assumptions, basic assumptions of why things work, are different than what you came from. And you know, from experience, they know what works best in their thing. But sometimes there are other things or better things that they didn't consider, because it is totally something they have never done before, something they've never used before. So
it's something that's not really in their view.
Exactly. I mean, it's a stretch to do that and things like that. Yeah. And I'm just thinking of, let's say, reverb furnaces in the aluminum side have some very interesting roof sidewall tie-in designs, which when I saw them the first time, my first thing was, gee, that would be nice to put in a reheat furnace in a steel mill. You know, they're just something that you just look at designs and you look at things and say, gee, yeah, we can use that somewhere else.
Oh, so being in different industries, you've actually been able to take ideas and concepts from, like you said, the aluminum industry, and be able to apply them to the steel industry.
Oh, yeah. Let's say electric furnaces. The induction furnace people have a moisture, because in induction furnaces, moisture, the coils contain water. So if you have a molten metal, you have cracks in the lining, or that is a leak from the coil itself, you will have an explosion. So they're very concerned about explosion. Just like in a vessel, if you have water under the steel, you have an explosion.
Yeah.
Exactly same concept, except it's in an induction furnace instead of a BOF, or an electric furnace. So they monitor, they have the ability or the equipment for that. And we're studying, I've recommended it to many places in the electric furnaces, because water-cooled panels have the tendency of developing holes, and the holes leak. And so you can get moisture into either the refractory of the bottom or the sidewall, or you can get moisture underneath the steel. You don't want either one of those things to happen. So, there's cross-fertilization, but you have to know they exist. It's not the case. It's a good idea, but if you don't know it exists, you can't apply it, you can't install it, you can't follow up on something like that.
Right. So what are some of the most notable changes that you've seen throughout the steel industry?
Much more technical. Much more technical than when I started out. It was very much if you would ask for properties or anything, it was a very much I'll take good care of you type. And now, I mean, that would just not make it. You definitely get technical information, be it on refractories, be it on the steel itself. I mean, they get tighter and tighter for everybody. I mean, not just that. The equipment has to work a certain way. You don't just get it and expect it to, well, it may or may not work. That doesn't fly anymore, that's why I say much more technical overall, everywhere.
So Ruth, you consult for a lot of different other industries outside of steel. Can you tell me a bit about some of those industries?
I can tell you about some of them. A lot of it is proprietary. Let's say right now, my work includes an incinerator. It's from a paper mill, and they want to recover some of the energy from that. I have a copper smelter that broke out, in 2011, and it is 2022 now. So, and that's for an insurance case. And I have a couple lime kilns that I'm working on for having refractory issues. So it's I cover many industries. It's been interesting because I started out in steel, of course, because people know me there and everything else. But with time and word of mouth, I guess, or my website, whatever, I'm getting all questions and jobs from many areas, many different industries.
Okay, so along with refractory help, do you also do any training or any other services?
Yes, I do two types of training. One of them is where it's personal, where I do go into a steel mill usually, or actually I've done it with refractory manufacturers and suppliers, where I go in and put on training seminars on refractories to cover the topics they are interested in. Those are tailored to we agree on the topics and we agree on what I should cover, and then I always, if it is a mill, I will go in ahead to make sure that I actually talk to the people on the floor to see what's going on, what are their concerns, what they perceive as the issues. And then I also do work with this AIST society, working on some of their training seminars. I don't put on the whole training seminar, but I participated as a trainer with some of them.
So which seminars have you been involved in?
For the AIST, I've been involved with specialty steels. I did the electric furnace when they still had a refractory section in there, which they haven't had in many years, and always participate in ladles and secondary metallurgy.
So what is one of the weirdest things that you've seen in your time throughout in this industry or other industries?
Well, I guess that would be dental implants. And when I was coming from a steel mill. I'm driving along on the highway, and I get this call, and it's this company, and it's a XYZ company, and they said, "We are having refractory problems. We make dental implants." And I'm thinking to myself, this is old, very old technology, and pretty much what could have changed? And I said, well, yeah, I mean, yes, I can go and see what you're doing, etc. And, what on earth can this be? So I get there, and they have these little trays which look like ashtrays, the size of an ashtray, that they fill with teeth. They are the teeth that then they put in the stem and they screw into your jaw. And I discovered that they're made out of zirconia, yttria stabilized zirconia. And they put several of these ashtrays, they stack them up inside this little furnace, which is about the size of a microwave. And they did have refractory issues. And one of the big problems is, which I did not realize for a long time, was coming from an integrated steel mill or working within steel companies, which are big companies, even the smaller ones are big companies. We go and buy refractories from the refractory company, the manufacturer of refractories. A small user of refractories, like this company or some of the induction foundries or some other things, they do not go to the company manufacturer. They go through a distributor that buys it. And so sometimes they just don't have the availability of either the technical knowledge that needs to be done, or even the products or the product quality control, products which have the quality control that needs to be done for some of these linings. And so this particular company was, how much refractory can you put in a microwave to fill in a hole in a microwave? Not much. So they could not really go out and buy, or access the technical know-how. Besides, they didn't know who to access. So actually, in this case, yes, I made suggestions of what product and how to install it, but I also gave them the access to one of the major insulating producers in the country, and I gave them the names of who to contact. So although they probably only buy, let's say, think of it as one roll of insulating blanket. I mean, it was not blanket, it was vacuum boards, but still, they now had the means and the ability to actually get the main one. It's what you cut off, we cut off, you know, or what we put in the dumpster, it would be sufficient to line this kiln. I mean, it is really, you know, the quantities are just so small that, you know, a manufacturer will not talk to them.
That's interesting. So you're able to kind of help them not only solve their problem, but connect them to a supplier that could actually help them
in the future.
Yes.
With developing. Yes, and they were developed, and the furnace was designed for the European code for the cold phase temperatures, which is much lower than the US. Well, I don't think we have a code for the temperature for cold phase, but they had it, and so it needed to be highly insulating, because it's a no burn, so you have to be able to, you don't touch it, you know, you don't hold on to it. Mm-hmm. That would be too hard. So yes, I mean, and as I said, it's not something that you necessarily think of when you, especially when all you have ever worked in is, you know, of course I will call XYZ company for this material. And that XYZ company is a the manufacturer of that material. Mm-hmm. It's not a distributor. So, I mean, it's just something that, again, it makes it interesting. You know, how do you solve the issues? It's going outside the U.S., you know, what companies, refractory companies do you have available? How reliable are they? What do you feel comfortable using? That's the other one is, of course, the customer needs to be comfortable using certain materials, using certain products and things like that.
That's interesting. So when did you first get involved with AIST and with AIME?
Well, not with AIST. Well, not with the AIST. I got involved with the ISS, which is the pre-runner of the AIST. And that was for several years. I was not considered to go to any of the big conventions. At that time, the ISS, Iron and Steel Society, mm-hmm. that's what it stands for, had divisions. There was the electric furnace division, there was the iron making division, and there was the steel making division, which was the BOFs. And so I guess we didn't make steel in the electric furnaces. I was electric furnace mainly. I mean, as mm-hmm. I said before, I didn't work much in the BOFs. So I was, you know, I didn't get to go. It was other things, and it takes a while before you feel comfortable enough into going into a big convention where you may not know many people. I mean, I was attending the Ceramic Society conventions, but not steel making or none of that was not it. So they had a special session on horizontal continuous casting. Must have been, I don't know, 84, 85, somewhere in there, let's make it second half of 80s. And so I submitted an abstract to it. I didn't tell my boss, though. I just submitted an abstract because I was doing much more, a lot of work on horizontal continuous mm-hmm. casting because we had one in Baltimore. I mean, I was in Baltimore every week. So, I mean, I would be Fridays, I might be in the office, maybe. But, you know, it was taken for granted. I was in Baltimore. So, as I say, I submitted an abstract that was accepted. And so then I went and told my boss, I'm going to be going to the electric furnace conference. I am giving a paper. So then I had to write the paper.
How did your boss react to that? Or...
He said, fine. I mean, he was very laid back about the things. I mean,
he just was like, oh, okay.
Okay, well, the biggest challenge was getting the, because being a big company, you put the paper out, you have to get a lot of sign-offs of different people, you have to send it to legal. That was much more of a challenge because it takes time to get all of these things done, etc. So yeah, so I presented the paper, that was my first one, it was Atlanta. And I discovered at that meeting that there was no refractory committee. Okay, the way they had the papers, sessions, and everything was organized by different committees, just like now they are. And I knew the BOF division had one. I knew the ironmaking definitely had a refractory committee because people from our group were involved in those. So, so that's why I say I knew the theory of it. I just had not participated. But nothing in the electric furnace. So I went and there was always a meeting of the board, and the committee, the electric furnace division committee, would have a meeting during the convention. And I went to that meeting. I crashed the meeting, basically. And I said, guys, you don't have a refractory committee. You don't have a refractory sessions. I basically volunteered to put one on. And during the big meeting, they said, no, not interested. By the time I got back to the office, and it was several days, etc., they called me, please put one on if you can. So I don't know what happened after I left, because I made my presentations and then I left. I mean, because I was not a member of the committee, of the division or anything. And so they had that. So for several years, we were what we called an ad hoc committee of me. And then I had a few other people who helped me, like Mike Fox and some other people. And then later on, we made a regular committee, not ad hoc, but we became a committee within the electric furnace division. And actually, I even went through the chairs. I was the chair of the electric furnace division because I was the chair of the committees. I mean, and that was on a rotation. And that one I was chair, I think it was in Nashville when I was a chair. That conference, we had the conference in early November. Couldn't be late November because of Thanksgiving. So yes, so that was how I got involved with it. And then once it became AIST, there was no refractory committee at the AIST. They took the different divisions, and there were several of us who said, oh, the AIME has a refractory, so we expected it to be automatic. But it wasn't. So it took several years of convincing, and the people that were on the refractory committee, at least from the electric furnace, several of us went into the Ladle committee because they were doing quite a bit of refractory work. That was when we got really involved with Ladle furnaces. We're having a lot of refractory issues, so and that's how the course. Ladles and Ladle refractory, secondary Ladle refractory course got not started, but resurrected. Because under the ISS, we had a lot of training conference meetings, and I participated. I mean, I put many Ladle refractory course together and put it on for them at that time. It was usually a one-day course instead of several days, and we did not do planned visits or anything like that. But it was interesting. And actually, the first one we did, we pretty much took my agenda because it was the first one under the new system. Flesh added some things, and what it is today has been added. I mean, it keeps increasing. It keeps reflecting the needs of the industry.
So how has membership benefited you in your career?
Oh my, the context, the personal, that you develop. It's one thing is the papers, but that's the technical content. But really and truly, it's also the people. I can call anybody, or they will call me, and we can throw around ideas. We will discuss problems. We will talk. If there is a new way of doing things, if there is a new technology, somebody is using it, how is it really working? Not the official necessarily things that are put out for for consumption, but how is it? What are the challenges? Because even if it is working fantastic, there are always challenges, and so a lot of these things come. It just create also friendship, many friendships from life. I mean, there are many people here who I've known for 20 plus or many years, and we will not go, keep track. Oh, what are you doing on a daily basis? But we know each other. We will make sure that it's taken care of. Things are done if something needs to be done, things like that. So the human part and the technical part both come together here in a beautiful way. I mean, it's very comfortable, very warm, and as I say, can be very technical if you need it.
So you've earned quite a few awards throughout your career, including, I'm going to go through all of them now. The 2021 ACERS Theodore J. Plange St. Louis Refractories Award. AIST Tech 2021, you won the Benjamin F. Fairless Award. And you were also a Distinguished Member and Fellow Award. And then going back to ISS in 1994, you won the Clarence E. Sims Award.
Yeah.
So can you tell me what all of these awards have meant to you?
It really gave me a lot of satisfaction for these awards because although I knew that my work was recognized and things like that, I mean, just talking to people, you get the sense, you get the feeling. But one thing is on a one-for-one type of a recognition. The other one is a public recognition of things. And there have been times when I felt that refractories are really ignored often through it. And so to have these kind of, especially in the steel part, kind of awards means that refractories and the work and the contribution of those things is percolating up. It does have an impact, even though there's some, they may be neglected, and I might complain bitterly about that. And it does give you satisfaction. The Plange Award was also very nice. Was extremely satisfying because within the refractories industry worldwide, really, is that award is given, and not coming from, well, by now I am part of that system, but originally not coming from that, and leaning on many people to learn, asking many questions. It's just good that it means that actually not only did I learn it, but I contributed to the furthering of it, and so that again is very satisfying.
That's awesome. So how do you think we can attract more young people into the industry?
I think that taking them out into the field. And I don't think that, going to universities and looking at ceramic engineering, I don't think will be the answer.
Okay.
Because people who go into ceramic engineering have a certain mental image of what that means. And that and a lot of them have the mental image of having superconductors or some very special niche kind of environment, very clean, very controlled. And I don't think I've ever been in an industry that has a very controlled environment. I think that taking them out on the field and showing them what refractories are, it's people who like to play in sandboxes and get dirty. That's why you have so many, let's say, geologists in it, because they got in the field. The reason most of us got into geology was because we went hiking or rock climbing and we're curious about what we're seeing around us. How did it form? What did it get to? So again, that's more what you need. If you're looking for somebody, I'm not saying that they shouldn't or that they should never do, consider that. But most of our environments are not controlled environments. Most of our environments are, oh my God, what happened now? And so a mindset of a very controlled environment will not work, will not be comfortable in under those circumstances. And that's why I say the people who played in the sandbox and got dirty, walked around in the rain because it was fun, not because they got caught in it, things like that. I think would probably be better served. I mean, the other thing is right now there are very few places where you can study refractories. So, we have to expand our views. Ceramic engineering is, again, also a very small number of people. So if we want to replenish the ranks, which we have to do anyway, we need to look at other areas. And, the oil industry is not going to be hiring every geologist that there is out there.
So we should start knocking on the doors of some geology departments and saying, you want to join refractories?
Yes, actually, yes, because, even under the good old days, which all they are really is old days, geology, the oil industry, which really hired many geologists, and that's where I really expected to work. I mean, I had what today would be an internship. It was a summer job with Mobil Oil in Denver. So really it's very cyclical, very similar to steel in that they have massive layoffs every so many years. And so not everybody is quite as enchanted with that concept as what it is. But that's what you think where you will be working. So you don't really think or consider other areas. So that's something to keep in mind. Or, I know that in practice, ChemEs, many of them go into the steel industry. So that's why I say it's different areas. Where did you learn the basics, the theory that can be developed and applied into other areas? And that's what it's going to be anyway for the rest of your life. You will be using your knowledge and stretching and going into new areas because nothing is static.
So what advice would you have for today's young leaders?
Learn as much as you can while you're in school. You may not like it. I mean, some of my most useful courses were not the ones I took because I had to fill my schedule, not because I was, quote unquote, interested in it. You will probably use it if it is within the general area, although you may not realize it at that time. You may not realize it later on that you're using it, except in hindsight, looking back. But the knowledge that you acquire, especially with the more theoretical things and more basic things, will be useful. It will not be, as I said, may not be directly applied, but you can use it. I have never found something of a report I wrote or a study I did. I may never have issued the darn report. I may not have finished writing it even, but I've always used the knowledge that I acquired with that area. So it doesn't go away, it just gets modified. And that's what I would say, you know, get that, and then just put yourself out there. You know, speak up, ask questions. Yeah, some of them will be so-called dumb questions or very basic questions. Usually what is thought of as a dumb question is a very basic question. You don't know. Just take it and go with it. You know, not all of us were born knowing everything.
I wish.
Yeah.
So what do you like the most about refractories?
The changes, the continuous challenges of how we can destroy them, new ways of destroying them. There's always a new way. There is always something different from place to place, from time to time.
So what do you think the biggest challenge would be for refractory engineers in the industry?
Figuring out why and actually trying to change it. I mean, we are always going to be chasing a hole. You know, you solved one, you will just give it, you will just be able to make room for a new one. You know, that's how it is. That keeps us in business too. Mm-hmm. And accept that there is no final answer to anything, because there will be new challenges, new ways of doing things. Therefore, there will be new ways of destroying the refractories. And that's how it is, and learn the whys, and so that you can chase a new hole.
So what has been your proudest achievement?
I would say that to be recognized that I contribute to maintaining or to the steel industry, and actually now it's other industries too. Mm-hmm. But the other thing is that it's amazing how small the world is of refractories. Just because I work mainly in the US does not mean that that is really the only place I'm known. I can get calls from other places. Hey, I am having this problem. How would you think about it? And it changed. There are different restraints or different issues, which are non-refractory issues. Let's say disposal issues. What materials can be used for what is available? Things. What does your workforce do? Where the structure of expenses. There are many things that need to be considered. But the fact that I can pretty much go anywhere in the world, and there will be somebody in refractories that if I need to, I can call on, or they will call on me. As I say, the family of the refractories people, the family not just of the steel, but also the subfamily of refractory people.
So what has made working in this field the most meaningful for you?
Solving the problem, mm-hmm. The problem in front of me. It's not the next. I mean, obviously, I don't know what the next one is, but being able to solve it and maintain continuity of things, teaching the new generations coming up, be it through the training seminars of the AIST or going into the mills and working with them, showing, even if I do just a failure analysis, I go in for that. I usually have somebody telling me, or why is this, why is that? And, you just kind of work through it, because none of us are going to be here forever, and the next generation generations need to know and need to see. And I find that there are fewer and fewer people who can. It's not that they cannot do it; it's that we are running so lean that they don't have the time often to explain, because taking a person who has not worked in the area takes quite a bit of time to show them, to explain, or the whys. We have new tools now to be able to pass on some of that knowledge, but nevertheless, a lot of it is just spending time with them, taking them out, showing them examples in the field, not pictures, but in the field, on how you look at it, why, what questions to ask, all those things, and there are not that many people who are able to do it because the knowledge may not be there, or are not able to do it because they don't have the time. They're not given the time to be able to do those things. And I was lucky. I had people who took the time to take me out to the mill, to take me to the blast furnace, to take me to different places and explain and tell me, you don't want to go there because X, Y, Z. I mean, it's, let's say it might be poisonous gases there, so you don't want to go there. I'll tell you if you need to go what to look for, but, or, you know, take into the pulpit and you can look at the screens, this is what it means. Pay attention to these numbers, these don't care, you don't care about those numbers. But it all takes time. And we don't always have the time these days anymore to do those things.
All right. Is there any other advice that you have for the audience or anything else you'd like to discuss?
I think that we've pretty much covered most of it.
Well, thank you, Ruth. It's been great to hear about what a fascinating career you've had, and it's been a pleasure to spend this time with you. Thank you again for your willingness to share your story with AIME.
Thank you for taking the time to interview me. I mean, and thank you for the AIME to put these things together, because it's all time, you know, and people, and we have to be cognizant that, you know, we don't have forever, and we need the time, and we need to preserve some of these things. So thank you.